All right, guys, so this is like the basis, like super basics of what we were going to cover today in class. So we've got 4 layers, the crust, the mantle, and then the 2 cores. Within those pieces, there's specific things that they do. So like with the crust, this is where our plates sit, and when the plates move around, we get these guys at the bottom of the screen. This is where we get our land features from based on the plate movement. But the mantle has what we call convection currents inside of it, and the convection currents are what drive all of the plates movement. The core, both cores combined, help with our magnetic field. For what we're going to talk about with the 3 layers, with the 3 major types of boundaries and what they create, this is not really a super important fact, but it's there, so there you go. The lithosphere was one of those vocabulary words on the layers lab when we looked at the fruit and the eggs. So the lithosphere is the crust itself and then the very upper part of the mantle. So this is where all of the convection currents are. So I'm going to move this so we can see a little bit better. So don't make fun of my pictures. The convection currents are heated by the core. So the core is really super hot. As the hot part of the core heats up the magma, because this is where the magma is, it's in the mantle. I've lost. Let's see if I can write this and it not look super. So this area in this space here between the green arrows and the part where it says core, this would be where my mantle is. So the core heats up the like jello-like non-Newtonian fluid and causes it to rise, because as heated molecules get more heated, they spread out. So if you think about solid liquid gases, we looked at when things go from a solid to a liquid, the particles get faster. And so as they speed up, they spread out, and as they spread out, they rise because they're less dense. Convection currents is all about how the less dense material rises and the more dense material sinks. So as it rises up, it's less dense and it spreads out, and it can cause plates to push apart from each other because it's causing the currents underneath it to move away. As it heats up, it starts to rise up, like we said. As it goes across the underneath of the crust in that lithosphere area, it starts to cool. As it starts to cool, it starts to sink back down. It gets close to the core, it heats up again, and then it starts that cycle. So we've got, with this convection current of heated materials rising, cooling materials sinking, we get 3 types of boundaries. We get a subduction boundary, we get divergent boundary, and then we get a convergent boundary. So there's another one called transform. We're going to look at that on the other side when I flip the board over. So with a subduction, I have an ocean, hence my blue water, colliding with a continental plate. The divergent boundaries usually happen out in the water or where there's an area surrounded by water. So we're going to look at 2 places in just a second. And then my convergent boundary is 2 continental plates that are colliding. So I'm going to flip this. And we're going to look at what those boundaries get us. So I'm going to have to move it so that we can see. So my 3 types of convergent boundaries. I have continent to continent, so they're both made out of granite. They're both the same material, so when they collide, eventually one of them will subduct just because it gets tired of pushing. Our example that they like to test on is the Himalayan Mountains, because they're both 2 continental plates moving. So if you look at the link in the description, it'll have an ebook that has a bunch more information about this. So the Himalayan Mountains are like the Indian continent and then the Asian continent, and they collide. They push up and make what's called folded mountains. The other one that could be on our test is a granite and basalt, or a continent and ocean collision. So the way I remember which one's which is basalt has the word salt in it, and underneath the ocean it's salty water. So granite is less heavy, so it pushes up. And then my basalt, because it's more dense, is going to subduct. That's the vocab word, is subduct or go under. And as it goes under, it gets recycled back into the magma. Now, one of the things that this can create, see if I can make sure my camera's not going to fall, is when it creates a volcano along with an ocean trench. So if it buckles enough or it collapses enough underneath the rock and has holes in it, the magma can come up and come out as lava in a volcano. More often than not, it creates mountain ranges and ocean trenches. Because this is a continent to ocean, this is really only going to happen near the coastal areas. The big one that they test on is the Chilean Trench off the coast of Chile. If you look, it is out in the middle. It's where an ocean plate is colliding with a continental plate. So when we do our map work, any of the ones that are where the arrows are going towards each other like this, and it's land and water, it's going to be this subduction zone. So then the next one is ocean to ocean convergence. When we have two plates collide and they're both oceans, they're both going to subduct. So when they both subduct, we get really, really deep trenches. And the one that they have put on the test previously has been the Marianas Trench. And I think that has an A in it somewhere, so don't judge my writing. So that's convergent. We have continent to continent, and there's a video where I do all these hand motions. Continent to continent, so when they come together, they push upwards and make mountains. I have continent to ocean, and when they connect, the ocean tries to go under and create, if you see the knuckles, on my left hand, it creates like a buckled mountain and a trench. And then you have ocean to ocean, and when they collide, they make a deep valley. So then we come to divergent. I know this picture looks really silly, and I'm going to explain it in a second. So I've got these two plates, and they're moving away from each other. So if you make a D, they dive away. When they move away from each other, magma from the mantle comes up and creates a new land. So that's what this picture is showing you. I started out with the original rock, and as it moved apart, I get new layers each time. This helps explain the mid-Atlantic ridge. So that's one of the things that it creates. So the land moves away from itself, or it dives away from itself. This is the only one where I get truly new land made. The magma creeps up and creates mountain ranges. Sometimes they're underwater, like the Mid-Atlantic Ridge. It's not on here. I need to put it right here, like Mid-Atlantic Ridge. Iceland is a prime example of this because Iceland is at the top of the Mid-Atlantic Ridge. If you think about the globe, like the South Pole, North Pole, Iceland is like right here on that ridge because the ridge runs the whole crack of the whole latitude line up. So Iceland is full of essentially earthquakes and volcanoes because this has a tendency to make volcanoes and mountains. The other one that is happening is the Great Rift Valley off the Horn of Africa. So these are two that we're going to label when we do our map. And then the last one is the transform boundary. So if you think about a transformer, when Bumblebee goes from a car to his Bumblebee transformer self, he does not take his wheel like off his body and then attach it somewhere else. They slide around on themselves. So this is where the plates actually are going to slide past each other. The shaking that we feel is from the release of those plates. So the plates are pushing and it's that jerk. It's not the actual movement. It's the fact that they've built up pressure and then they slide. So if you've ever like pushed on each other's hands and all of a sudden they slide past, that push past is what gives us this energy release. If these happen out in the ocean, they can cause a tsunami. And the two big ones that they try to make sure we cover are the San Andreas Fault in California and then basically all of Japan, because Japan is very, very close. The whole little country is very close to a fault line. So I hope this helps. I'm going to post 2 videos in the description. One will be notes. No, 3 videos. One will be notes from a couple years ago that have more details in it, so if you want to look into it more. 2 will be me doing my little hand jive motions. And then the third one will be the ebook link with all of this in it. So I hope this helps. Please take notes over this, because we're going to have to hit it pretty quick. I'm going to guess we're going to miss 2 days of school. Love your faces.